are going to solve a 2018 paper 1 final exam, which is an internal paper which was written by Grade 12. So we are going to solve question 1 to question 2. So question 1 was saying find the value of x raised to 0 times 2 raised to 3. So we need to understand to say anything which is raised to 0 it's the same as 1 times 2 raised to 3 it's the same as 2 times 2 times 2. So we multiply 2 3 times. So of which when we multiply 1 times 2 it is 2 times 2 it is 4 times 2 it is 8. So we need to write our 8 here. So this is our answer. So remember, as we are solving paper 1 final exam, we need to do the calculation under this space given here. All our calculation need to be done under this given space here, and the final answer need to be written here where there is the answer and then a space given. So this is free 2 marks that we need to enjoy under paper 1. So we go to the second question saying factorize completely. We have 18 minus 2x raised to 2. Okay, so for us to factorize this, we are going first of all to factorize by a common factor. So by a common factor, it's a rule which says that we need to identify a common number or letter that is appearing both on the first term and the second term. So in this question, we only have a common number, which is a 2. Okay, so we write 2, open bracket. So 2 is a common factor because 2 can go into 18 without leaving remainder. The same 2 can go into negative 2x squared without leaving a remainder. So 2 into 18 is 9 minus 2 into negative 2x squared, it is negative x squared. So negative x squared like that. So here, as I said earlier on, we are factorized by a common factor. A common factor method. We are factorized by a common factor method. So remember, the question is saying factorize completely. So we need to check whether inside here we can factorize further. Yes, of which we can, because this is a difference of 2 squares. So we can write it as 2. So 9 is the same as 3 squared minus x squared, like that. So let me change my color to red. Okay, so now this is equal to, so what is inside here, it's a difference of 2 squares. So mean that we're going to have 2, then we're going to have 3 minus x, then we open another bracket to say 3 plus x, because it's difference of 2 squares. So our answer, will write it here to be 2, open bracket, 3 minus x, close bracket, open bracket, another one, 3 plus x. So this is our answer. As usual, all the calculation under paper 1 need to be shown here on this space. The final answer, we need to indicate it on the answer space given. So we'll go to the last question. Last question is saying z is a point negative 1, 8 and m is a point 2, 12. Find the magnitude of Zm. So we have Z, which is negative 1, 8, and then M, which is 2, 12. Then we are looking for the magnitude of this vector. So there are two formulas that we can use here. We have the first formula, let me write it here. The first formula can be the magnitude of vector Zm. So we use the modulus, this modulus, to show that this is the magnitude that we are looking for. So we can use the formula, the root of x2 minus x1 everything squared plus y2 minus y1 everything squared. Or we can say the modulus of vector Zm is equal to x squared plus y squared. So now let me explain to you in what condition you are supposed to use this formula and what condition you are supposed to use this formula. So the first formula, this one, So this formula here, which I've written here, you need to use it if you have been given two coordinates. For example, here we have been given coordinate z and coordinate m. So we can use this formula. This formula, if you have been given the resultant vector, the resultant vector will only contain the x coordinate and the y coordinate. So meaning that if you want from this Zm, we can first of all calculate the resultant vector of Zm. After knowing the resultant vector, that's when now we can use this. So if we use this method and if we go back to this method, the answer remains the same. However, for me, I'll use this method here. Okay, so we are going to have Zm, the modulus of vector Zm is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so after stating our formula, we need to choose which one would like to be our 2's, which one would like to be our 1's coordinate. So for this purpose, let me just choose m, coordinate m to contain the 2's. So mean that here we're going to have x2, here we are going to have y2. Okay, then this simply means that z coordinate to contain x1, y coordinate to contain, sorry, the z coordinate will also contain y1, like that. So now we can easily substitute. So we are going to have x2, which is 2 minus -1, okay, squared, plus y2, it's 12 minus 8. Okay, so of which we are going to have 2 negative times negative, it's a positive. So positive 1 squared, okay, like that, plus 12 minus 8 is 4 squared, of which this is the same as 2 plus 1. 2 plus 1 we know is 3 squared plus 4 squared. Okay, let's come here. So what is 3 squared? It is 9 plus 4 squared, it is 16. So of which we are going to have 9 plus 16, it is 25. Okay, so this is the magnitude of vector Zm is equal to, so the square root of 25, remember this is purely paper 1, no calculator is allowed. So this is, and we know that 25 here, it's a perfect root. Okay, it's a perfect root, so there's no need of even using a calculator. Okay, so we know that the square root of 25 is what? 5. Now we need to indicate the unit. Is it centimeters, millimeters, kilometers? However, under vectors, we just say 5 units. So this is the modulus. Okay, so remember, after doing this calculation, we need to indicate the final answer here to say it's 5 units. So this is our answer. Hope you have enjoyed the simple calculation of 2018 paper 1, question 1 to question 3. So this has been Maths Layer. Thank you.